Alright guys, welcome to an Explain Everything video for Lesson 3.3. Today we're going to talk about how to prove lines are parallel. So I know you guys are pumped up about that. Alright guys, so more theorems for us. Today we're starting with the converse of the corresponding angles theorem. And basically this just tells me that if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So over here, taking a look at it with a picture, if angle 2 is congruent to angle 6, then we can prove that line L is parallel to line M. And if you remember from last class, yesterday, angles 2 and angle 6, those two would be corresponding angles. So it's kind of the reverse of what we learned yesterday, that if angle 2 and angle 6 are congruent, then we could conclude that those angles are parallel. Okay, so problem 1 is identifying parallel lines. Which lines are parallel if angles 1 and angle 2 are congruent? And so the first thing that I do is I try to figure out what is the relationship between angle 1 and angle 2. And angle 1 and angle 2, those guys are corresponding angles. If you take a look, they are both below the lines, below line A, below line B, and they are actually on the same side as line M. That makes line M my transversal, and therefore I could conclude that A is parallel to B. So those would be my two parallel lines. And I could prove this by the converse, what we just talked about, of the corresponding angles theorem. On this screen, you can see it's just the answer to the problem that we just talked about doing. All right, so this would basically be a you-try problem in class, but since I am not here today, we are going to go ahead and just work this one out together. The question says, which lines are parallel if angle 6 was congruent to angle 7? And it's very similar to the last one. You can see that angle 6 and angle 7, those two would be corresponding angles. So therefore, line L would have to be parallel to line M. And so if those two are parallel, the way we could prove this would be that converse of the corresponding angles theorem. All right, moving on, we have our second theorem for today. This is the converse of the alternate interior angles theorem. So reading it, it says if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. So once again, class, this is just putting in reverse what we talked about yesterday. Now it's saying if angle 4 is congruent to angle 6, then, yeah, we could conclude that line L is parallel to line M. Couple more theorems. This is the converse of the same side interior angles postulate and the converse of the alternate exterior angles theorem. And it's basically the same thing. It's working in reverse. So up here it's saying if the measures of angle 3 and angle 6 add up to 180, then line L is parallel to line M. That's because angles 3 and angle 6, those are same side interior angles. Or remember from the IXL, they talked about these being consecutive interior angles. And so if you have a pair of same side interior angles that add up to 180, then you could conclude that the lines would be parallel, okay? And down here at the bottom, we're talking about the converse of the alternate exterior angles. And this one is basically saying, okay, if angle 1 and angle 7 would be congruent, then we would know that line L is parallel to line M. Okay, guys, so here's your favorite thing in the world. We're going to take a look at a proof of the converse of the alternate interior angles theorem. And they're doing this in something new, something called a flow proof. It's kind of like a flow chart. It's the same stuff that we listed in a 2-column proof and a paragraph proof, but now we're going to have arrows to show like, okay, step 1 leads to step 2, and so on and so forth. And with a flow proof, the reasons are written below the statements. Okay, so if we take a look, it says proof of theorem 3.5, converse of the alternate interior angles. The given is that angle 4 is congruent to angle 6, and we're supposed to prove that line L is parallel to line M. So over here, they start off with my given information. Angle 4 is congruent to angle 6. The reason is listed below. That's given. Okay, from there, they say that angle 2 is congruent to angle 4, and the reason that they're listing for that is vertical angles are congruent. So now we know that angles 4 and 6 are congruent, angle 4 and 2 are congruent, and then what we can do is we can go right to our good old transitive property to now cut out those middle pieces, cut out those angle 4s, and we put together that angles 2 and angle 6 are congruent. And so if angles 2 and 6 are congruent, then we can go to line L is parallel to line M, and we're going to use our reason that the if corresponding angles are congruent, then the lines are parallel. So here we are at problem 2. We're going to write a flow proof of theorem 3.7. It is all worked out, but remember, it is important that we read these and we take a look at these so we know how to do them. So in this particular problem, my given is that angle 1 is congruent to angle 7, and my job is to prove that line L is parallel to line M. So if we look down here at the bottom, we start again with our given. Angle 1 is congruent to angle 7. The reason is given. From there, they add on that angle 3 is congruent to angle 1, and the reason that they're giving there is that vertical angles are congruent. Okay, so if you do this same way that we did the last problem, if we cut out those middle pieces and use my transitive property, we can now prove that angle 3 is congruent to angle 7. If angle 3 and angle 7 are congruent, then we know that line L is parallel to line M, and it's that same reason. If corresponding angles are congruent, then the lines are parallel. Okay, so here it is a proof that we have to do, and it starts off by just saying use the same diagram from problem 2. So I'm just going to go ahead and draw that in for us. We had line L and line M. So there's L, there's M. I've got my transversal here, and then my angles were numbered 1, 3, 5, 6, and 7. Okay, so that is the figure from problem 2, and in this problem, my given is a little bit different. My given is that angle 3 and angle 6 add up to be 180. So what I know is that those two are my same side interior angles, which means that they do add up to be 180. That's the given. I have to prove that line L is parallel to line M. If you scroll to the next page, you'll see the worked out flow chart. I really want you to take a look at that and read it, just because this is kind of tricky stuff. Here we can see that flow chart for the got it problem where we had to do the proof. It starts off by saying the measures of angle 3 and 6 are 180. That was the given. And from there, it went on to say that 6 and 7 equals 180 because that was a linear pair. So then they put those two together. Measure of angle 3 and 6 has to equal 6 and 7. You can see right here, measure of angle 6, they subtracted that from each side. So that's my subtraction property. That gives me that 3 equals 7. We can there go to that 3 is congruent to 7. And bada bing, bada boom, line L is parallel to line M. That's that if corresponding angles are congruent, then the lines are parallel. Okay, here we are on problem 3. We're going to try to determine whether parallel lines are, or whether lines are parallel. We've got a little bit of a scenario here. It says the fence gate shown below is made up of pieces of wood arranged in various directions. Suppose angle 1 is congruent to angle 2, so I've just highlighted those in blue. It wants to know if R and S are parallel, and here, guys, we could say yes. The first thing I always try to do is figure out what's the relationship between angle 1 and angle 2. Angle 1 and angle 2, those would be alternate because they're on opposite sides of the transversal, and they would be exterior angles because they're outside of those two lines R and S. And so the reason I can say yes, that the lines are parallel, is that alternate exterior angles, if those two are congruent, then the lines are parallel. That's that converse of the alternate exterior angles theorem. All right, so this would be a you try in class, and it's asking about in problem 3, what is another way to explain why R is parallel to S. So I'm going to just kind of draw what we had there minus the cat. So here's R, here's S. This was the transversal, and your angles were 3 and 2 and 1. And if we're trying to take a look at another way of proving that R and S are parallel, the way that we could do that is we could say that, well, angles 2 would be congruent to angle 3. And if you think for a moment why we can say 3 and 2 are congruent, hopefully you're with me in knowing that those are vertical angles. And so if 2 and 3 are congruent, then angles 1 and 3 would also be congruent, and the reason we could use there would be the transitive property. Okay, so yes, R would be parallel to S by the converse of corresponding angles theorem. All right, folks, coming here to problem 4, we're going to now get to use algebra to find the value of x for which A would be parallel to B. The first thing I always do, guys, is take a look at the angles that they give you. In this case, it's the 2x plus 9 and the 111, and I'm thinking about what's the relationship between those two. Those two are same side interior angles, and I know that same side interior angles are supplementary. And so what we can do is we can come up with an equation just like what they did down below. They did 2x plus 9 plus the 111 and set that equal to 180. From there, they solve it. They combine like terms, so they added the 9 and the 111 to get the 120. They subtracted 120 on each side, so that gave them 2x equals 60. And finally divide by 2, so we get x equals 30. That's what they wanted. They wanted the value of x, so from there I know I'm done. Okay, guys, once again, these would be like some you tries in class. So for number 1, it wants me to state the theorem or postulate that proves that line A is parallel to line B. If we take a peek at these two angles, pretty much all I need to do is figure out what's the relationship of those two angles, and those angles are corresponding. So we're going to use the converse of the corresponding angles theorem. Okay, number 2, again, state the theorem or postulate that proves A is parallel to B. If we take a look, I see that this angle is congruent to this angle. they would both be 65. Then telling me y degrees right there really doesn't matter, because if I just take a look at these two angles, the 65-degree angles, I can figure out that relationship. And those two angles are alternate interior angles. So we would use this B, converse of the alternate interior angles theorem. And finally, number 3, they want to know what is the value of y for which A is parallel to B. So if we take a look, one of the things that we know immediately is if this angle down here is 65, then this one is also 65. That's because they said that these two are congruent. I could then figure out y because I know that this is a linear pair. So I know that y plus 65 has to equal 180. If we subtract 65, we end up getting y equals 115 degrees. So answer choice B. All right, folks, that's the end of lesson 3.3. I know it was a bit choppy, not my best work, but hopefully you're all good. I want you guys to go ahead and start the 3.3 practice. It's in Canvas. This is really going to be due by Monday. So Monday in class, I will go over everything. If you have any questions, don't panic. I know this is a little unusual way to do the lesson. Hope you guys have a great weekend, and I'll see you on Monday.